Alright, let's take a look at the Module 6 review. So we're dealing with those transformations, some congruent triangles, and all that stuff. If you haven't already done the frame, go take a look at that frame video. You can get that frame, bring it, and use it in class. And hopefully you've still got those calculator worksheets because they have some rules that can help out a lot. So first let's start with some translations. So remember, translation, another word for it is a slide. So we've got the rule here that tells us how we're moving it. So the x value and the y value are going to be adjusted. Our point is right here. It's at 2, 5. Yeah, 2, 5. So we're going to subtract 4 and subtract 2. So one way to do it is to write the point and then just subtract. 2 minus 4 is negative 2. 5 minus 2 is 3. So our new point would be at negative 2, positive 3. Okay, so that would be k prime. So you could do it that way, or you could just count. X to the minus 4 means to the left. 1, 2, 3, 4. Y minus 2 down 2, 1, 2. Same thing. Okay, so you can do it more mathematically or more visually. Either way works. Second one, we've got our pre-image G. We're going x plus 7, y plus 3. So x plus 7 would go 1, 2, 3, 4, 5, 6, 7. And then up 3, 1, 2, 3. So there would be G prime. Which, if we just took our variables, negative 2 and negative 5, and if we added 3, and if we added 7, that would put us at positive 5 and negative 2, which is what G's point ends up being. So either way on translations you can deal with them. Alright, now reflections. The easiest way to think about a reflection is first figure out what line you're reflecting it over. So x equals negative 2. So I go on the x-axis to negative 2. That's my invisible line I'm reflecting it. So I imagine folding it over, and that e is going to just fold over to the right the same amount of spaces. So we get e prime. Okay, same with 4. So y equals negative 1 is this line right here at y-axis of negative 1. So we're 1 away from it, so we just move across the side, 1, and there's J prime. There's our image. Okay, if you have a slanted line, you draw the slanted line and then just mark it and make a box out of it. Same idea. Okay, now rotations. Now you had some rules that could be helpful, and let me pull those up if I can. Okay, we had these rules for rotate at 90 degrees counterclockwise, rotate 180 degrees counterclockwise, or 270 degrees counterclockwise. Now the 270 was like the 90 degrees clockwise as well. Okay, so a 90 degree counterclockwise, look at our points. Our B, our pre-image, is at positive 2, negative 5. Okay, the rule for 90 counterclockwise, say we swap the x and the y becomes negative. So our y is already started out negative, so it would make it a positive 5, comma 2. So positive 5, 2. There's our rotation 90 degrees counterclockwise. And we could kind of check that. I'd have to just have that one piece. No, that's not going to work, is it? Oh well. Now I'm just going all over the place. There we go. Okay. So that's one way to think about it. The other way to try to think more visually is, look, this is your y-axis. We're rotating that y-axis 90 degrees, so it'll become your x-axis. So I went down 5, so I would go to the right 5. And that's where it would go on that point. Then you think in terms of, this is my x-axis, and I go out 2, so I'm going to rotate that 90 degrees up here, and I go up 2, so that's where it's going to be. So where do they connect? Right there. So that rule can be easier, or the other way can be easier. Kind of depends on which one you're doing. Now, rotation 180 about the origin. So my x is back 3, so it's going to be to the right 3, because we're flipping it around. And it's down 1, so I'd flip that around, and I'd go up 1, so my point would be right there. Or I could get that point of -3, -1, and then I just change the signs because that's what the rule is for 180. Doesn't matter if it's clockwise or counterclockwise. So it would be a positive 3, positive 1. Alright, now we got to go backwards. Now we're given something and we got to decide what the rule is. So if I look at all of these, notice the one that doesn't seem, the reflection should be pretty apparent, that somehow it's going to be the opposite, right? So number 8, let's look at that one first. So find that imaginary line. Okay, these are 2 away. These are 1, 2, 3, 4, 5, 6, 7, 8 away. Well, what's half of 2? It's 1. What's half of 8? It's 4. So I go 1, 2, 3, 4. 1, 1. That gives me that middle line where it's reflecting over, right? So what is that line? Well, it's horizontal, so it's y equals, and it's positive 1. So I'd say reflection over y equals 1. There's my rule. Okay, for 7 and 9, for translations, you're still going to remain your shapes in the same kind of the way that they'll look the same. They won't be flipped around or anything. So we should know that that's the translation. So I say I start with my x and my y value, and what are we going to do to it? Well, this c, to get to this c, we go 1, 2, 3, 4, 5. So the x value is to the right 5, so the x value adds 5, and then down 1. So the y value subtracts 1. Or you could say right 5, down 1. That works too. And you can double check it. 1, 2, 3, 4, 5, down 1. 1, 2, 3, 4, 5, down 1 with the other ones. So there's our way to write the rules on that one. Now number 9, the reflections are often the toughest ones. But basically, you're going to rotate it. Okay, you could rotate it left or right, clockwise or counterclockwise. If I'm going clockwise, that one's pretty easy to see. I see the S is connected to this one, and then it just jumps down right there. And each of these ones jump over. So I'm only moving from one quadrant to the next, which tells me it's 90 degrees if I move clockwise. So I'd put rotate clockwise 90 degrees, or 90 degrees clockwise. I could also do it counterclockwise, but then I'd have to go 720 degrees. So rotate 720 counterclockwise. Alright. Okay, now we're talking about the triangle congruency ideas. So you've got about basically 5 choices here. You've either got side, side, side. It's congruent because all sides are congruent. Side, angle, side. It's congruent because the 2 sides and an angle in between are congruent. And when I say in between, I mean these 2 sides form that angle. Angle, side, angle, where it's the side and then the 2 angles that it's connected to. Angle, angle, side, where you have 2 angles and another side. Or they're not congruent. There's not enough information to tell us. Not congruent, no, not enough information. So we start out by deciding what we share. Now remember, you've got that x, and the 2 angles across, when they're connected by those angles, are called vertical angles, and they're the same. So I've got those angles that are the same, so mark it, angle. I've got another angle that's the same. And my side, is it in between? No. So it's yes by angle, angle, side. Number 11, we've got that vertical angle, so I know those 2 angles are congruent. So 2 angles that are congruent and a side in between. So that's yes by angle, side, angle. Number 12, I've got a side, and an angle. Okay, that doesn't follow any of ours, so we can say not congruent, or not enough info. Okay, 13, we've got an angle, and then a side and a side. But where are they? Okay, well, that angle is in between our 2 sides, right? Those 2 sides form that angle. So it's yes by side, angle, side. This one, had this angle been right here, it would have been the same one, but it's not, so you can't use it. So, if we're looking at number 14, we are taking a look at that triangle. So same idea. So they share a side. Whenever they share a side, we consider that congruent. So a side, an angle, and a side. The angle's in between those two sides. So yes, by side, angle, side. Okay, 15. Two angles and the side in between, so yes, by angle, side, angle. Number 16, they share a side, and we've got an angle and a side not in between, so yes, by angle, angle, side. Number 17, they share a side and one angle. It's not enough information, so not congruent. 18, three sides, so yes, by side, side, side. 19, three sides, so yes, by side, side, side. Okay? So moving on, we have a blank page. Okay, interesting. Okay. So on these next four, you're taking the rule and you're telling me what else we need to have that's congruent. So like on 20, it's side, side, side. We've got one side, two sides. So we need a third side. Well, where's our third side? Right here and here. So I'd have to write UW is congruent to CE. That's what it wants to know. Okay, number 21, angle, angle, side. So I've got an angle there, okay, and a side here. Now, if I choose this angle as my other one, that would be side, angle, side, but we want angle, angle, side. So we've got an angle and a side, so we need an angle that's not going to be next to that side, basically. So the only angle not next to that side is Q and F. So we'd write angle Q is congruent to angle F. Okay, 22, angle, side, angle. So we've got the two angles, so now we need the side in between, the side that both angles touch, which is that side and that side. So ST is congruent to CB. And the last one, side, angle, side. We share a side. We've got an angle. So what's the other side touching that angle? It's that one and that one. So AB is congruent to CT. Alright, so there's those first ones. Now, for these last ones, we're going to draw some lines of symmetry. Don't pay attention to this yet. We'll use that in the next one. Okay, so lines of symmetry, remember, those are how we can fold it over. So here, I could draw a line of symmetry there. I could draw one right here. I could draw one right here, or here, or here, or here. So there's 1, 2, 3, 4, 5, 6. 25, parallelogram. Okay, where could we fold that one over? Could we do a horizontal? Nope, because that edge would come down right there, right? Can't do a vertical, and even a diagonal doesn't work. So you just write none, or just the parallelogram's sad, but it can't be symmetrical when it's sad, so it has to be sad like that. Poor parallelograms. Alright, now degrees of rotation. Remember, that means if we take our image and rotate it, how far do we have to rotate it to get it to stay in the same shape? So remember, the trick is take the number of sides. Because a circle is 360, go 360 divided by the number of sides. That'll give you your answer. 4 goes into 36, 90, 360, 90 times. So it's 90 degrees. Now, this last question is having you apply some rules to this. And so it's going to be A, B, and C. And that's our triangle. And then we need to do first a translation. So the translate x minus 2, x minus 6. So we're moving them to the left 2, down 6. So to the left 2, down 1, 2, 3, 4, 5, 6. To the left 2, down 1, 2, 3, 4, 5, 6. to left 2, 1, 2, down 1, 2, 3, 4, 5, 6. And it tells us to label that triangle A prime, B prime, C prime. So we've got our triangle, so it'll be A prime, B prime, C prime. Now we're going to continue, and we're going to then rotate this 90 degrees clockwise. So we're rotating it this way. Okay, so it's C prime is pretty easy because it's here at 4, so you're just going to rotate it down to this one at 4. That's C double prime, because we want to label that with the 2. Okay, B, we go to the right 2 up 1, so we're going to go down 2 to the right 1. So it's actually right where A prime is now, B double prime. And for A, we go to the right 1, down 2. Remember, 1, negative 2, that rule we had. So let's go back and find it. Okay, so that rule of moving 90 degrees clockwise, the X and Y change and the X becomes negative. Okay, so let's take a look at that and go back. So X and Y change, X is negative. So the X and Y change and X becomes negative. So it would be negative 2, negative 1. So negative 2, negative 1, which puts it right, oops, in purple, right there. Right. Oh, negative 2, duh. Negative 2, negative 1, right there. That looks better. And that's A double prime. Okay, so on the test, you'll get a point for getting here, a point for getting here. So you can get partial points for doing at least some. Now, the last step is we're going to reflect over the line x equals 1. Okay, so x equals 1 would be a vertical line right here, right? I'm going to erase this stuff. Well, no, I won't. So B double prime is right on the line, so it's going to stay right on the line. So that'll now be B triple prime. Okay, A is 1, 2, 3 away, so we go 1, 2, 3. So here's A triple prime. And C is 1 away, so C goes right here and becomes C triple prime. And there we go. Kind of a crazy, messy looking thing, right? But it works. So, there we go. There's the review. And good luck, guys. Get it done. Make sure you have those notes. Be ready for that test. And we will see you later.